Welcome to another episode of Code for Thought. A lot of what we do in science is writing notes, whether that's for research or for lectures, writing articles about our work, and of course trying to get them published. To say that documents are an important part of our work is pretty much an understatement. And so having the right tool to help you with that can make your life a lot easier. Say hello to Pandoc, described as a Swiss Army knife of handling and converting documents. I came across Pandoc on social media in 2024 and got intrigued. It's open source and has a pretty strong following. And not only that, it is used, as you will hear later, by publishers like the Journal of Open Source Software in their publishing workflow. The history of Pandoc is no less interesting. It was created by J MacFarlane, professor for philosophy at Berkeley University in California in the US. And I contacted John to see if he would be willing to talk to me about his work on Pandoc, and lucky for me, he agreed to meet with me. He suggested we also invite the core developer on the project, Pandoc, Albert Krewinkel, based in Berlin, Germany. We met for a recording about half a year ago in autumn 2024 to talk about how the project came about, how Pandoc can help with managing your documents, and also what's in store for the tool in the future. So, without further ado, let me hand over to John and Albert, and you'll be hearing from Albert first.
Yes, I'm Albert. As you said, I'm Berlin-based. I'm in my 40s by now. Now I'm working as a software engineer, but I used to do stuff like mathematics and molecular biology, but that's a long time ago now.
John.
Hi, I'm J MacFarlane. I'm a professor of philosophy at University of California, Berkeley. And I'm also a hobbyist software developer, I guess. I maintain a number of open source projects, most prominently Pandoc.
Maybe John, I think you started working on Pandoc. Maybe you can start talking about what it is and what it's used for.
Sure. So Pandoc is a universal document converter, or strives to be a universal document format converter. You would use Pandoc to convert a document from one format to another, and Pandoc handles a large number of formats, including XML formats like DocBook and HTML, LaTeX, Context, man pages, light markup formats like Markdown and restructured text, Word documents. So if you want to convert a Word document to a LaTeX file, you can use Pandoc. If you want to convert a document from Markdown to a Word file, you can use Pandoc. You can use Pandoc to write a Unix man page. So there's a whole bunch of things you can do with it. I would say that in addition to its role as a conversion software, I think of it as a tool for writing, and particularly using its most well-supported native format, which is Pandoc's Markdown variant. You can write articles, particularly academic articles. You can include math. You can include citations, which Pandoc will automatically resolve for you and create the requisite bibliography entries. And you can take the source document and you can convert it to whatever format is needed for the application that you've got. So you can put an HTML version on your web page, and if the journal says they want a Word document, you can send them that. You can make a nice PDF via LaTeX. So that's one of the ways that I use it primarily, is I just use it for most of my writing.
When did it actually start? I mean, the development on Pandoc. And when was the first version made public?
The first version was in 2006, actually. I think I started working on it in 2006, but I might have started in 2005. I'm not quite sure. I'm a long-time sort of computer hobbyist, going back to when I was a kid, essentially. And that was the day when being a computer hobbyist meant like fiddling around with machine language and things like that. But, anyway, I heard about this language called Haskell from a philosopher friend, and I thought I would check it out. And I immediately took a liking to it. And I thought that by way of learning it, I would try to write something. And recently, Markdown had come out. John Gruber had published the spec for Markdown. And so I thought, well, maybe I'll try writing a parser for this light markup format, because Haskell is a good language for writing parsers. And so I did that. And then I thought, well, parser's not much good without something to render it. So I wrote a renderer for HTML, and then I wrote one for for LaTeX. And then I thought, I've got all these documents that I've been writing in restructured text, which I was using at that time for lecture notes and things like that. So if I could convert those to Markdown, then I could start using my own tool. So I wrote a parser, pretty primitive for restructured text, and then a renderer for Markdown. So then Pandoc was starting to take shape, and it has this modular structure where it has a number of parsers which take an input document and produce a internal representation of the document. And then it has a number of renderers which write that representation to different formats. And so one by one, we just started adding parsers and renderers to it. And then at some point, I stuck it on my website and said, here's a thing. You can use it if you want. I had no experience with open source software at that time other than using it. And then what happened is, I didn't really expect anyone to even notice it, but for some reason, some people noticed it. And Debian developer trainee, who was training to become a Debian developer named Rajai Aktosh, contacted me and said he wanted to package this for Debian Linux. And so that started to happen. I learned a lot about open source software from working through that process with him. And then once it was there, of course, that dramatically increased its exposure and it started to kind of take off.
I actually came across it on social media, on Mastodon, where I think somebody pointed out Pandoc. And so I'm quite fascinated by it for a number of reasons. One is the choice of language, because people might be familiar with Python nowadays. A lot of scientists are working with Python. There are other languages like C++, well, maybe not for text formatting. I haven't heard many people talking about Haskell, but maybe we can come back to that later. Albert, so what was your route into Pandoc and what are you doing there at the moment?
I started a good bit later. So I think my first contact was sometime in 2013, maybe. I similarly, I was interested in Haskell. I came from Lisp and really liked the functional programming idea. And people kept telling me, well, you have to try Haskell because it's even better. I started to look into that and wanted to find out about programs written in Haskell. And of course, Pandoc was right there, and it was this very popular program. So I took a liking to that and I wanted to use it. And then I realized, it can't handle arg mode, this format that's used in Emacs quite a bit. People use it in all kinds of ways, but it can't be read into Pandoc. At the time, Pandoc was able to output arg mode, but couldn't read it. So I figured, that might be an interesting project to start. I think it took me 3 tries to actually get something. I broke it off 2 times and then 3 times the charm, actually got something working and was able to pull up a pull request. And John really helped me to get that into a state that is actually usable. My first try, let's say it wasn't quite there. But yeah, that was my introduction to Pandoc and my first contribution. And
the first thing that strikes me is the open source. So going for open source and making it public. But then, John, you said that you had no experience with the open source community. And Albert, you're also coming from shall we say, computer science background. So how did you actually work out how to contribute and how to deal with contributions? Did this evolve naturally that you choose, hey, there's GitHub and I think it might be helpful? How did you come across that and how did this work out?
Yeah, well, actually, when we started out, there wasn't GitHub.
Yeah, in 2006, there wasn't, no.
There wasn't. It came around later. After a while, I put the code on Google Code, which was around before GitHub. And so that was the original thing. And, there really weren't contributors for quite a while. There are not that many people in the Haskell community anyway. So my first experience with the open source aspects was really working with Rajai Aktosh about packaging issues. And Debian has a lot of protocols for their packages. And so I learned a lot from that. And I remember reading an online book about open source software at about the time that really fascinated me. And I'm sorry, I don't remember the name of it, but it was just
but it's a shame.
how open source software works. And I just sort of found it philosophically fascinating, for one thing, that there's this thing at all, that people just put their labor into this stuff and put it out there for free. Part of the reason that works is because of open source licenses, because normally you wouldn't want to put your labor into somebody else's project because it's their project, but it's open source. So that means that you will be able to keep using any of this stuff in perpetuity. that's part of why it works, but it's still kind of fascinating to me. Anyway, that book had some nice advice about how to set up mailing lists and things like that. So I did those things.
Mm.
And then, of course, when GitHub came out, it really started to take off much more because it was much easier for people to discover your project and contribute to it.
I think initially they didn't actually have all these management tools that come with it. I think pull requests were there quite early on. I remember that.
In a way, I think the project being in Haskell has been somewhat helpful because there's a limited number of people who can contribute to a Haskell project compared to, say, JavaScript or something like that. And it's probably good to keep the number of contributors down because all of it has to kind of go through me in the end, and that's a bottleneck. And I already can't keep up with everything. But the fact that there are not that many people who can contribute has in a way been helpful. It's kept the project to a manageable size and rate of increase for me.
And also give you time to learn maybe how to deal with all this kind of contributions and how to handle that.
Sure, yeah. And also I think that typically the people who know Haskell are good programmers, so that raises the overall quality level.
Albert, how was it for you to dive into this world of open source and suddenly, you're contributing to an open source package?
It was a lot of fun. I had people introduce me before to the idea and talk about it a lot, but I think this was the first time that I actually really, really contributed something more than just a couple of lines. I was incredibly thrilled when the version that contained my contributions was finally published, and to see people react to that and be happy, like, whoa, Pandoc supports Erg mode. And that was quite a high for at least a week or something.
Well, okay, it's a long-lasting one.
Actually, Albert hasn't mentioned it, but we should talk about what his biggest contribution to Pandoc has been, which isn't the org mode reader, but rather the whole ecosystem around Lua filters. At some point in Pandoc's development, I introduced the idea of a filter. So the thought was, let's give users the ability to modify the abstract syntax tree of the parsed document before it's written. That gives you a lot of flexibility to customize things. And so the way it was originally implemented is Pandoc would emit a JSON representation of the internal data structure. And then your filter would read that and then do whatever it wants with it and emit another JSON data structure. Pandoc would take that in, and then it would render whatever the resulting document was. So your filter was literally a Unix pipe that took JSON input and emitted JSON output. And you could write that in any language, but we had a really nice system for writing them in Haskell. In a way, that was super elegant because all of Pandoc's types are in Haskell, and you could write these filters in Haskell, and it all worked really well. Now, the problem with that, though, was that in order to use a filter, you had to have a Haskell compiler on your system. And you had to figure out how to compile Haskell programs and how to install the dependencies and things like that, which got increasingly complicated. You definitely couldn't advise somebody who was having a problem, just use a filter, because then you're saying, well, first, install a Haskell compiler on your system. It'll probably take only about 2 gigabytes and all the dependencies of Pandoc, whatever. And so I started to think about what could we do to make this more accessible. And there was a Lua bridge library in Haskell, HS Lua, which embedded a Lua interpreter, and it allowed you to interface between a Haskell program and the Lua. Mm-hmm. For example, exposing Haskell data to Lua. We said, well, let's provide the ability to write filters in Lua. And let's build the Lua interpreter right into Pandoc, so you don't even need to install anything besides Pandoc. You just write the little Lua program. Okay, so this is the thing that Albert started working on and has been working on ever since. And, it was an interesting engineering project in a way, because it's like we wanted to make the Lua interface as close as possible to the Haskell so that the filters were really sort of elegant and simple and easy to understand. And so that took some doing. And so there's quite a big ecosystem of libraries that Albert has written that interface between Pandoc's Haskell types and Pandoc's functions and Lua. It's very capable, and you can do a ton with the Lua filter system. Maybe I should let Albert talk more about what you can do and what people have done with it.
Yeah, indeed, Albert. So over to you. And it's also interesting to see, you're now a core developer of Pandoc. I mean, I picked it up from the site. So exactly when did that happen? So was that with the filter that John just mentioned?
I think that happened when I wanted to write a paper about Pandoc, and I asked John, like, hey, I'm not sure which affiliation to mention in the paper. Can I use Pandoc core developer? Is that okay? And John went, yeah, sure. So that's when I kind of started to use that. Interestingly, that paper also was the start for Lua filters, because my co-author, Robert Winkler, wanted to use Pandoc for science publishing tasks more and make it easier to use for people, to give them more options and have some predefined templates to make it closer to how scientists in the natural sciences, for example, would use it.
Mm-hmm.
And I wrote a couple of things and used Python filters, which existed already at the time, but needed to have Python installed. And he didn't like that because that required extra software and it wouldn't work on Windows. That pushed me into the direction of writing Lua filters. And yes, so that filter gave the impulse to do the work that I'm still working on right now.
The one question that we haven't touched on yet, why Haskell in the first place? I mean, you touched on it briefly, John, because you said you found the language fascinating. But one of the problems is, as you mentioned, which worked in your favor when you actually made it open source, but one of the problems is there aren't that many people who might be familiar with it. There may not be many people who know how to install it and run on their computer. So what made you choose Haskell? What does it bring to the table?
Well, one thing is that it's quite fun to program in Haskell. And because of that, I like working on Pandoc. And so maybe Pandoc wouldn't exist if it weren't in Haskell. Second thing is that Haskell is really a very good language for doing the kind of stuff Pandoc does for a variety of reasons. It's got a super expressive type system, so you can express a lot of the constraints that you want to impose in the types themselves. That prevents a lot of bugs and a lot of issues from arising. It is a pure language, or at least, encourages you to write pure functions that don't have side effects. And when there are side effects, that has to be clear from the types.
Could you clarify to the listener what you mean by pure function?
Sure. So a pure function is one that whenever it gets the same input, it's going to give the same output, and it's not going to do anything else. Not going to change a global variable that might change the functioning of something elsewhere. It's not going to print something out. It's not going to delete a file on the disk or anything like that. All it's going to do is take this input and change it in this deterministic way. And very often that's kind of just the function you want in this sort of a project. You want to transform a document to another format. Actually, this ability to keep track of your side effects is something that we use in Pandoc with the sandbox option that you can use. Let me back up. Pandoc can be used as a Haskell library, and there's also a command line program. When you use the library, you have a choice actually between running things in a context which allows I/O or running them in a context that doesn't allow I/O. If you, for example, are running a web server and you want to be very, very sure that no attacker can use your Pandoc document conversion thing to, for example, delete a file or get access to a file somewhere on your system, you can run it in a context that doesn't allow any I/O. Then you can be really confident that nothing like that will happen. There's some tricky attacks that, you don't necessarily think about, like some formats like restructured text have include files.
Yes.
And, so you can include, .. /X password or something like that. And then, in your output document, you get this file from somewhere on the file system. You don't want that to happen. So you want to play it safe. You can run Pandoc in a mode where the readers and writers, the actual functions that do the parsing and rendering, won't do any I/O at all. So the only I/O involved is guaranteed to be reading the file, the input file, and then writing the output file, essentially. So that's one place where we use it. But just generally using pure functions like that is a good way to write clean code that has fewer bugs, because you know that what this bit of code is doing is not going to mess with something else in your system. And I've written parsers in other languages too. I have written common mark parsers in C and in JavaScript, TypeScript. So I have experience maintaining projects that are written in other languages, and I've written parsers in Lua as well. And it's just much nicer to maintain a project in Haskell, because I don't like having to fix bugs in the other project, because whenever I fix something, I always have to worry about whether my fix is messing something up. And in Haskell, I often just know that I don't have to worry about that. Another thing that Haskell is extremely good for is refactoring.
Okay.
So you want to change something. Often that involves changing the types of a function or something like that. And then you can just change it and then just try to compile your program, and the compiler will tell you sort of everything that needs to be changed to make it work. And generally, when you change all those things, it works. That's not something that you can generally do in other languages, in my experience.
Haskell, as I remember, I mean, I've never programmed in Haskell, but I had a discussion once about property-based testing, which actually is based, I believe, on a library or on a tool that was written in Haskell first.
That's right, yeah.
And is that something that you employ there as well? Because I think it was one of the advantages of...
Yeah, we do some property-based testing, not as much as I'd like, but partly that's because the parsers and renderers in Pandoc are all, they're not perfect. And, with such a universal scope, I think the Markdown one is good. But when you're dealing with something like LaTeX, there's no way you could 100% accuracy parse everything. If we were striving for 100% accuracy in the parsers and renderers, for example, we could try doing property tests on round trips, for example, as a way of testing to make sure that parsing, rendering, parsing back gives you the same content. And we do that sometimes, and I do that sometimes just to find bugs. So there are definitely places in the code where we use property-based testing, but we should probably use it more.
As far as I understand, so you have Pandoc either as a Haskell library or as a command line tool. And what it does, it takes in a format, it parses that, it creates this kind of intermediate state that is expressed in JSON. Did I get this right? Before it converts it into another one, which then gets also written in JSON before it actually gets rendered?
Yeah, the intermediate state is just a Haskell data structure. You could write it in Haskell. There's a Haskell Pandoc type.
Right.
You could write a Haskell expression that encodes the document. We can represent that as JSON. So we have a kind of mapping between that and JSON. If you need to communicate with the outside world, if you need to pass this data structure to something besides Haskell, you can use that. But the JSON doesn't actually play a role in the Pandoc conversions.
Okay, yeah. I wanted to clarify that because we mentioned that we talked about this in context of the filters where you actually are communicating with the outside world.
But the Lua filters don't actually need to use the JSON.
Right.
Because the Lua interface just taps right into the Haskell stuff. For that reason, it's also much faster.
You mentioned also something about the Pandoc Markdown version. So how is this different to Markdown, the box standard Markdown that people might know?
Well, the original Markdown was described on a web page that John Gruber put out, and it's fairly limited in what you can do. And so as Pandoc developed and I wanted to use it for more complex kinds of writing, I started adding some features. A lot of those features were added in conversation with people who were also working on extended versions of Markdown at the time, for example, PHP Markdown Extra. And so I tried as far as possible to use things that other people were using. So, for example, footnotes and LaTeX math, a lot more fancier list markers, so it's not just 1, 2, 3, but you can use Roman numeral lists, automatically numbered example lists, citations, and lots of other features like that, the ability to put in figures. So all these things that you might need in academic writing that aren't in the original version of Markdown. And so this became known as sort of Pandoc's Markdown variant. And actually in Pandoc, you can sort of enable and disable each of these additions in a fine-grained way if you want to. Now, later on, I was involved in this standardization effort, which led to the Common Mark spec. Because Pandoc's original Markdown parser, predates that by quite a long time, it isn't really a superset of that exactly, although I'd like it to move in that direction with time. But Pandoc will also parse Common Mark and a lot of extensions to Common Mark, including GitHub flavored Markdown.
Albert, you mentioned molecular biology and life sciences.
That's right.
And was Pandoc then your route into becoming a software engineer?
That started a little bit earlier. I think Lisp was my real route into software engineering. I have no idea how that came to be, but I installed it on my computer and I just found it incredibly fascinating how I could write recursive functions and use it in ways I couldn't have dreamed about. Lisp is very good at meta programming where you can write programs that write programs. And that was mind-blowing to me as a young student. over time, I realized, oh, I think I actually like this better than spending my time in a wet lab and looking at petri dishes. So I decided, okay, let's go that way. And first I went into mathematics and then finally all the way into software engineering.
The core development of Pandoc is part of what you're doing. It's not, or are you full-time on this?
Now I'm full-time working on things related to Pandoc, really, since 2020, I think.
Right,
So right when the pandemic started.
You mentioned publications a number of times, and I like to understand a bit more how Pandoc fits in with the publication workflow from a scientist's point of view, and then maybe we can talk a little bit about what it means in terms of publishing your stuff. So how does it fit in? So where do you use Pandoc in your writing?
I use it mostly for presentations, really. Like, I rarely write articles. I do write articles now and then, but I write far more presentations than articles. And Pandoc is also extremely good at being able to just type out one's thoughts and then structure them into something that can then become a presentation. That's how I started. And the paper that I mentioned, where we proposed, well, Pandoc is an excellent tool to write reproducible articles because people can include their code and the code can be then executed and checked, and everything is in one central document, which is kind of neat. And people do use these ideas in practice now. So one example is the Journal of Open Source Software, where the people can actually hand in articles through GitHub, and everything, like the whole review process happens on GitHub. And the publishing is, of course, handled by Pandoc. So all the publishing artifacts are then generated through Pandoc, and we generate, of course, PDF output. We could generate HTML pages. There are certain formats that are very important for indexing, which is called JATs. So those are needed by databases like PubMed, where all the scientific articles get indexed. Yes, so that is one example. And the other one would be Krato, which is a very nice tool built on top of Pandoc. It uses a lot of the Lua features, and it contains many extensions where it's easier to embed code and run it and have graphs generated through Python code or through R code. Yeah, it does get used in this way. And I think they're, especially in data science, it's a really important and often used tool by now.
How does Pandoc actually do that? I can understand that you can write stuff yourself, sort of like a markdown or whatever it is, and then convert it into something else. How does it pull in the code or some data? How does this mechanism work so that you can get a reproducible article?
It basically works by first doing the whole parsing step and then doing all the further processing on the internal document representation. In that document representation, we have one element for code blocks. So we can pick out all code blocks and then see what attributes are there on that code block, whether it's a Python code block. And if it's a Python code block, then we can pass it off to the Python interpreter and actually run it. And depending on the results, if it generates an image, then we can include the image, or if it's just text output, then we can include that. Again, this one central document format is really key to the whole conversion process because it makes it very easy to actually act on the elements and not just on the text of the document.
It's like a digital Rosetta Stone. Is that how we can imagine that?
I'd say so.
John, I think in your work as a professor, you probably have to publish quite a lot. I guess that you're using Pandoc quite extensively then, which is probably the reason why you created it in the first place.
I wouldn't say it's the reason why. I mean, I think the reason why is essentially procrastination. I probably had a paper due or something, and I was like, oh, I can't bring myself to work on this, so let me fiddle around with Haskell a bit. But, I do use it a lot. Let me just tell you some of the things I use it for. So all my notes for teaching, lectures, seminars, all that, that's all done in Pandoc. I don't actually use slides all that much, but when I do, I always generate those in Pandoc. All the letters I need to write, official sort of letters, I use Pandoc. It's great. I just write the content of the letter and boom, letterhead, everything is automatically generated. For publications, I use Pandoc for a large amount of what I write, but not quite everything.
Uh-huh.
Usually I use it for articles because in my field, annoyingly, many journals will want the article to be submitted in Word format, and they won't accept like a tech document. And so I'll just write it in Pandoc's Markdown, and then I'll convert it to whatever format they need at the end. For books, I've usually used just LaTeX throughout because it's a little more powerful in terms of getting everything dialed down exactly like you want. It has more powerful cross-reference capabilities than Pandoc does at the moment, and so on. So Pandoc isn't quite up to where I'd want it to be for writing a book yet. Although the thing I'm working on right now, I am doing in Pandoc. So maybe it's getting there. But yeah, I use it for quite a lot of my writing. I mean, Albert mentioned a Journal of Open Source Software. I believe there's also some philosophy journals that use Pandoc in their pipeline.
What's next for Pandoc then? So what does the future hold?
Right. What is next? There's some things that we still need to fill in, like they're holes. They're construction holes that need to be filled in. So, for example, a few years ago, we changed the type for representing tables to allow much more complexity in tables to be represented. Before it was just like a table was a grid. And if you wanted to have cells that spanned rows or like intermediate column heads or something like that, forget it. But now we have all this flexibility in the table representation, but the parsers and renderers haven't all caught up yet. There's a lot of tasks that are open on the bug tracker that if someone cares to do, would be important to do, like fully implementing all the features that tables now support in the Markdown writer or in the restructured text reader, stuff like that. I mean, we've got a lot, but we don't have quite everything. So there's a lot of tasks like that need to be done. The big thing that I would love to do something better about, well, a couple things in terms of academic writing would be some better syntax for representing figures. And this is something that projects like Carto have kind of worked around doing their own thing, which is fine, but it'd be nice to have something built in. And then a much more flexible method for doing cross-references. For example, C equation 5 or C section 13.
The usual stuff you do in articles.
Which Tech has a very sophisticated and flexible system for doing that. And I'd like to have something like that in Pandoc. Right now, you can do that in Pandoc using kind of third-party filters, but something like that ought to be built in. And that's kind of a big project that I guess I haven't really had the bandwidth to undertake. And partly it's a design issue. It's not clear how to design that feature. We don't want Pandoc Markdown documents to look too much like computer code. We'd like to design it so that it doesn't use English language keywords. And it's tricky to figure out how to design these features subject to those constraints. But that would be one thing that I would really like to accomplish. Albert, what am I missing? What am I forgetting?
One point where I'm really interested to get that forward is completely different. I want to get younger people on board to Pandoc to make sure that it will exist for a long time, because I think it would be a shame if it wasn't maintained at some point. So it's important to bring in, new people, new coders. And I mean, John mentioned in the beginning that there aren't too many people working on Haskell, but a lot of code, a lot of contributions actually were made by people who didn't know Haskell.
That's absolutely true. The original org mode writer was contributed by a guy who says, well, I didn't know any Haskell, but I just sort of looked at some of the other writers and wrote this, and it compiled. You don't necessarily need to know that much Haskell to make some contributions to Pandoc. And we don't typically use many of the more fancy features of Haskell that are conceptually difficult. It's probably a good project for beginners to get their feet wet in Haskell.
Which is a nice segue into my final question. So how do people get involved? How can they get involved?
Well, if you go to the GitHub bug tracker, we do try to mark some issues with good first issue labels. Those are issues that we think are manageable by somebody who's new to the project. So you could pick one of those and see if you can fix it. You might want to communicate with us first and talk about what you're planning to do. And sometimes we can give good advice and so on. Learning Haskell would be good, but as I'm saying, you don't need to learn everything about Haskell to contribute to Pandoc. You certainly want to have some basic knowledge of it, but you might not need that much knowledge of it to contribute.
That means don't be scared. Don't be scared of Haskell.
There's things in Haskell that other people do that I don't really understand. So, I mean, there's a lot of depth to it. You can go very far in the way of abstraction. And we just don't go that far in the way of abstraction in Pandoc.
Okay.
Partly because when I started the project, I barely even knew Haskell when I was writing it. And I'm sure I would have done a lot of things differently if I knew what I knew now. But in a way, it's good that the project has a kind of fairly simple structure to it.
Okay. How many contributors do you have at the moment?
Historically, the number of people who have contributed, certainly probably a couple hundred or something.
Maybe?
I don't know. There's an authors file in the repository. You can look at that. Of course, some of the people there made very minor contributions, but there have not been that many people who have made a sustained number of major contributions. Over a period, I would say probably about 7 or 8 people.
I would have guessed 20, maybe.
Well, it depends. It depends what the sort of threshold is. For major and sustained period and so on. There have only been a handful of people who've contributed to the level that Albert has, for example. Jesse Rosenthal, who's actually a professor of English at Johns Hopkins, did a ton for Pandoc, and he wrote the Word document parser, which is a very tricky piece of code. I mean, anything dealing with Microsoft formats is a total, it's a total nightmare to get on top of. And he was a major contributor for a long time. And there have been several others like that over the years, but right now, Albert's the main other person who's contributing a lot at one time, but at any given time, there'll be somebody who's doing something interesting. And so I would hope that we'll have more contributors going forward.
I would also like to encourage people to think about whether they have nice ideas, and then we can try to, for example, get it into a project like Google Summer of Code or Haskell Summer of Code and work from there.
Right, that's true. And, we've had, I've mentored one person. I think maybe Albert has mentored somebody.
I did.
I worked with Matthew Pickering on the Pandoc stuff, and he wrote the EPUB reader and did a bunch of stuff involving tech math conversion, which has been really helpful. And now he's working on the Haskell compiler. That was great. I had a whole summer, and it was actually terrible for me for my academic work, actually, because he was very keen and he was a fast worker, and he was in England. So, I'd wake up in the morning and there'd be all this stuff that he had done. Instead of doing what I should do, I had to work on Pandoc for a while, and then the next morning it would repeat.
How do you actually square that? Albert, you're now working full time on it, but John, you're still giving lectures. How do you go from Immanuel Kant to Haskell and back?
Yeah, for me, it's a nice, different kind of activity that I can engage in. It offers some things that are similar to philosophy, kind of abstract thinking and problem solving and so on. But one thing that it offers that philosophy often doesn't is it's very, very clear when you've got it right. And I think that kind of feedback is really nice. It's really nice to produce something where people go, yeah, I used that and it really worked. That's not something that happens in my other work all that much. So for me, it's something that I feel brings some balance to my life. But as far as the time demands, it is tough. I don't have a huge amount of time to spend on it, and I spend more time on it than I should be. And it's always a bit of a struggle there. I can't really abandon the project now, though. It's kind of like my child, and there's all these users and there's bug reports, and they get under my skin because I like it to work. So it's always very motivating for me to fix bugs, and I like doing that.
Well, which is to say, thank you very much for your time. And, I think we can all appreciate how precious that is. And thank you very much for your time, Albert. And I think you two and all the others contributors have their work cut out to keep Pandoc going and growing.
Yes.
We'll keep busy for a while.
Yes. A lot of work to do. So check out the code base, ask questions. We're happy to answer questions on the GitHub discussions and contribute. It'd be great.
As you've just heard from John and Albert, the team is looking for other contributors, even if you're not that familiar with Haskell, so don't let that hold you back. You'll find the links to Pandoc and the GitHub repo in the show notes. Pandoc, by the way, is not the only tool John has created. On his website, you'll find quite a list of other software tools John created over the years. Well, next week is the last week in May 2025, so time for another episode in the German language. And this time, I'll be diving into the world of large language models with my guests Karina Haupt and Christoph Stenkamp from the German Air and Space Agency DLR. See you then. Oh, time's up. See you next time. But before I forget, This podcast is covered by the Creative Commons license. See ya!